Hello, students. Welcome back to the fourth episode of Solving 45 Expected Questions Daily for your upcoming NEET 2025. I hope this will be helpful for NEET 2026 aspirants as well. And today we will be discussing important questions on amines, a crucial topic for your exam. And remember, the secret to getting ahead is getting started. So let's begin. Question number one. The reduction of nitro compound is most preferred in the presence of palladium hydrogenation in ethanol, reaction with tin and HCl, finely divided nickel, and iron scrap and HCl. Remember, reduction with iron scrap and HCl is preferred because ferrous chloride form gets hydrolyzed to release HCl during the reaction. Thus, only a small amount of HCl is required to initiate the reaction. So the correct answer will be D. Clear? Question number two. Orthonitrophenol is less soluble in water than P and M nitrophenol because orthonitrophenol is more volatile than those of M and P isomers. Orthonitrophenol shows intramolecular hydrogen bonding and it shows intermolecular hydrogen bonding. The melting point of orthonitrophenol is lower than those of P and M isomers. So you can draw the structure just to help you understand better the structure of orthonitrophenol. This is your benzene ring and hydroxy group is present here. Nitro. Now there will be intramolecular hydrogen bonding present in orthonitrophenol. It shows intramolecular, not intermolecular, and it forms something like chelate. Compounds involving inchelation become nonpolar, remember, and consequently such compounds are soluble in nonpolar solvents like ether, benzene, etc., and are only sparingly soluble in water, which is polar in nature. So, whereas in the case of meta and para isomers, they are more soluble in water and less soluble in nonpolar solvents. So, the correct answer for this will be B. It shows intramolecular hydrogen bonding. Clear? Question number three. In the reaction of aniline, a colored product C was obtained. So, if you look at the sequence of this reaction, A aniline reacts with nitrous acid in cold condition gives B, and again treated with this amine gives C. Question is asking find the correct answer. So now let us write the product B. Basically this is a diazotization process, and in the diazotization of aniline yields diazonium chloride. This will give benzene diazonium chloride, and after treatment with this N,N-dimethyl aniline, which is given here, N,N-dimethyl aniline, in the cold condition, it will give your para product. The compound will look like this. Nitrogen, double bond, and that N,N-ethyl methyl part will come here. Name of this compound will be called para dimethyl aminobenzene. Aminobenzene. So this will be the name of the product C. Okay, so let us see the options available for question number 3. I have just explained that C will be para dimethyl aminobenzene. So correct answer will be for question number 3. Yes, it will be D. Para dimethyl aminobenzene. Question number 4. The number of primary amines of formula C4H11N will be 1, 3, 4, 2. Different types of numbers are given here. What will be the correct answer for this question? Question number 4. Remember, primary amines have NH2 group in their structure. Four primary amines are possible for this formula C4H11N. So if you can draw the structure, it would be helpful. CH2 and H2. This is number one structure with the formula C4H11N. And the second structure, which is C4H11N, also can look in this form. Can be a secondary amine. Structure number two. Moving on, I'll write in the top for structure number three with the formula C4H11N will be, yes, you can expand this structure. CH2, still a primary amine, but it is having a branch alkyl group. Structure number four, we shall see how many possible structures can be drawn. So if you look at these structures, you can answer that the number of primary amines that can be formed with the formula C4H11N will be 4. Okay, these are all primary amines. Let us see question number 5. Which of the following reactions will not give a primary amine? Amide on bromination with alcoholic potassium hydroxide or reduction, cyanide and isocyanide. Okay. So to answer question number 5, you have to remember this methyl isocyanide on reduction with lithium aluminum hydride gives secondary amine. This will not give primary amine. So answer will be option number C. Others, they're all going to give primary amine. Okay, we'll come to question number 6. Which one of the following method is neither meant for the synthesis nor for separation of amines? Number 1, Curtius reaction, Wurtz reaction, Hoffman method, and Hinsberg reaction, which is neither meant for synthesis of amines. See, Wurtz reaction, you have learned this for the preparation of alkanes from haloalkanes. So this is not the answer for question number 6. Wurtz reaction. Question number 7. Among the following, the most basic compound is option A, paranitroaniline, B, acetanilide, C, aniline, D, benzylamine. So benzylamine, this is the most basic. Okay, let us draw the structure of benzylamine. You have benzene ring, SCH2 and NH2. You have lone pair of electrons and nitrogen atom. This is the most basic in characters. In others, the basic character is suppressed due to resonance. But here, you're not going to expect that much of effect in case of benzylamine. So option D will be the correct answer. In the case of nitroaniline, acetanilide, aniline, they are all going to be influenced and the basic character is suppressed due to resonance. So the most basic compound will be benzylamine. Clear? Question number 8. Which of the following is not correct? You're given different types of statement. Read, ethylamine and aniline have both NH2 group. Ethylamine and aniline dissolves in HCl. Ethylamine and aniline both react with chloroform and potassium hydroxide having a foul-smelling compound. Ethylamine and aniline both react with nitrous acid in coal condition to give hydroxy compounds. So this nitrous acid react with differently with this aliphatic group and aromatic amines in cold condition. So the behavior is different. So I can write the structure of this primary amine can be ethanamine H2. Let me rewrite the structure of nitrous acid in this way. HNO2, same thing. Nitrogen gas will be evolved in this reaction and alcohol will be formed. Now, in the case of aromatic amines like aniline, you have benzene ring, which is aromatic. Aromatic amines when you treat this with nitrous acid derived from your sodium nitrite and hydrochloric acid in the cold condition, okay, this is cold condition nitrous acid, it will form benzene disonium chloride and a salt will be formed, N2Cl minus. So read the statement. Ethylamine and aniline both react with nitrous acid in cold condition. So this will be the answer. D. Question number 9. Let us read fast. Yes. What is the question asking? 10. Okay. When bromination of aniline is carried out by protecting the NH2 group, the product is, it will be a mixture of ortho and para because it is ortho para directing in nature. Ortho and para bromo aniline. Okay. Let's see question number 11. Ethyl isocyanate and on hydrolysis in acidic medium generates. You can write the structure and give the answer for this question. CH3, CH2, and C. This is ethyl isocyanate. It will have a foul smell. In the acidic medium, this gives your amine, primary amine plus acetic acid. Uh, it will not be acetic acid, it will give rise to formic acid. HCOOH. So 11 answer will be ethylamine salt and methanoic acid is formed. Correct answer will be D. Question number 12. Which of the following is the strongest base in aqueous solution? The strongest base. See, aromatic amines are less basic than aliphatic amines. Among the aliphatic amines, the order of basicity will follow secondary, primary, and tertiary. This is the order. Okay, and the electron density will decrease from tertiary amine due to crowding of this alkyl group over nitrogen atom, and that is the reason for this decreasing order. All right, so as this tertiary amine, due to crowding of alkyl group over the nitrogen atom, it makes the approach and the bonding by proton relatively difficult. Therefore, the basicity will decrease, and further, this phenyl group present will show minus I effect. And if this minus I effect is shown, it decreases the electron density on nitrogen atom. Because as you know, minus I effect, uh, it takes electron rather than giving electron in the case of plus I effect like you have seen in methyl methoxy group. Okay, this phenyl group, since it is showing minus I effect, it decreases the electron density on the nitrogen atom and hence decreases the basicity. So correct answer for question number 12 will be dimethylamine. Clear? Let us move on to question number 13. Tautomerism will be exhibited by which of the following? The nitro compounds having alpha hydrogen group shows tautomerism. I will write the structure of one nitro compound here, a primary nitroalkane. So tautomerism can be shown. If it shows tautomerism, it gives this type of structure. Okay, so alpha hydrogen, if it contains alpha hydrogen, that nitro compound will have this phenomena of tautomerism. So you have alpha hydrogen here, you have tautomerism. The answer for this will be option number D. But in the case of the remaining three, you are going to find there is no alpha hydrogen. Whenever alpha hydrogen is present, you have this phenomena. All right, question number 14. Amongst the following compounds, given compounds, the one that would form a brilliant colored on treatment with sodium nitrite in HCl, or you can say nitrous acid, followed by addition to an alkaline solution of beta naphtol is? To answer this question, you should know that only primary aromatic amines undergo diazotization followed by coupling reaction. So find out which is the primary aromatic amines. Definitely this one, right? So answer option number C for question number 14. Let us see the next question, question number 15. Among the given set of reactants, the most appropriate for preparing secondary amine is? See, secondary amine can be prepared by reacting primary amine with an aldehyde followed by reduction. So which is the correct answer? C. Question number 16. In the chemical reaction given below, okay, this is, you might be familiar with this reaction. This is the carbalamine reaction. Okay, just find out the product, then you have the answer. So in carbalamine reaction, a very foul smelling gas is formed. That foul smelling gas is called isocyanate. Okay, and with also the release of potassium chloride and water molecule. Water is already given 3 molecules of water. To balance this, you write here 3. Because you have how many potassium? 3. So option, the compound A will be ethyl isocyanate and potassium chloride. So for question number 16, answer will be A. I hope it's clear. Question number 17. Read out the question. Which of the following is not an explosive? See, to find explosive, explosives invariably contain 2 or more nitro groups. Okay, hence this amino toluene doesn't have any nitro group and it is not an explosive. You have to find that it should contain 2 or more nitro groups to be called explosives. Okay, it should contain 2 or more nitro groups, then the definition of explosive will be satisfied. See, if you study carefully, except B, others will all have 2 or more nitro group. In the case of orthoaminotoluene, you are going to have only one amino group. So there is no nitro group. So this will not be an explosive. Question number 18. Which of the following reagents will be useful to distinguish between the 2 types of amines? See, the first compound will give azodine, okay? Whereas the second one, it will not form azodine because nitrogen is not linked directly to the this phenyl group. For question number 18, this first compound will give azodine. You can write the structure of the dye that is likely to be formed by compound A. If it forms azodine, coupling reaction will take place like this. So you can distinguish easily which of the following reagent will be useful to distinguish between these two. The first will form azodine. Okay, the first compound will give azodine with nitrous acid and beta naphtol. Question number 19. High basicity of methylamine relative to trimethylamine is attributed to which of the following answer? Remember, secondary amines are more basic than tertiary amines due to the stabilization of secondary amine by hydrogen bond. So answer will be A. Remember, there must be solvent. Question number 20. The major product of the reaction of the following uh, amines in sodium nitrite with sulfuric acid will form which of the following major product? This is a question. Question number 20. So when you react this mixture, the major product that will be likely formed is this product, ketone. Let us read question number 21. Which of the which reaction sequence would be best to prepare 3-chloroaniline from benzene? 3-chloroaniline from benzene. So the starting material will be benzene. When benzene is treated with nitric acid and sulfuric acid at a temperature of 333 Kelvin, you are likely to obtain, this is nitrating mixture, so nitro group is introduced on this benzene ring, and further chlorination in the presence of iron to this nitrobenzene will result in meta isomer, metachloride chlorobenzene. Then on reduction with this, you are going to obtain reduction, as you know, it will be elimination of oxygen gives amine. So what is the name of this product? B. Metachloroaniline. So nitration, chlorination, and reduction. 3-chloroaniline is prepared from benzene by first nitration, then chlorination, then followed by reduction. This will be the answer. Question number 22. In the following set of reaction, X is. So what will be X? When bromination takes place, it gives Y. From Y, it gives Z. Z, it gives tribromobenzene. So you have to build up the structure of X starting from this final product, tribromobenzene. So since it has a benzene ring, likely X must be aniline. Because on bromination of this aniline, you are going to obtain in bromine water 2,4,6 tribromoaniline. 2,4,6 tribromoaniline. Okay, in cold condition, if I treat this with nitrous, same thing. Okay, the reagent, these two will give nitrous acid because one will go as sodium chloride and nitrous acid will be formed. And in the presence of this nitrous acid, the reaction will be giving disonium chloride because nitration of aniline gives disonium salt. And if you treat this disonium salt in alcohol, the final product will be elimination of this disonium chloride because nitrogen gas can no longer be present on this disonium salt. It has to be eliminated as nitrogen gas, and chlorine will go with this ethanol. So treat this with ethanol. The final product will be tribromobenzene. Okay, a benzene ring. This will be the final product. I hope it's all clear. Let us see question number 23. Yes. And if you would further like me to clarify any questions, you can comment, okay, in the comment section. Amine and treated with this ethanol chloride in excess gives A. What will be the answer? This is actually acylation. Acylation of amine occurs in one step only because lone pair of nitrogen is delocalized with the acyl group like this. This lone pair is localized. So I have to move this double bond to this oxygen because this lone pair attacks on this carbon. And now I'm going to obtain salt. Double bond comes here, oxygen minus, then CH3. So basically the product A will be amide. I hope this is clear. Let us see question number 24. The alkene formed as a major product in the elimination reaction given above will be. So find the reaction. So how to approach this? This is actually according to a rule called Hofmann's rule. See, when theoretically more than one type of alkenes are possible in the elimination reaction, the alkene containing least alkylated double bond is going to be formed. So forget about this reaction. Let me rewrite again. Here you have the substituent, which is your methyl, then nitrogen linked with another methyl. You have N-butyl normal straight chain having 4 carbon. When this mixture is heated strongly, what are you going to generate? Methyl, then N nitrogen, methyl as it is, then normal butyl. This ethyl part will leave as ethene because this is an elimination reaction by also forming a byproduct water. This is going to be ethane. So question is asking the alkene formed as a major product in the above elimination reaction will be ethene. This is in accordance with Hoffman's rule. So it states when theoretically more than one type of alkenes are possible, the alkene containing least alkylated double bond, that is going to be the major product. Least alkylated double bond. Question number 25. An ethylbenzene sulfonylamide is strongly acidic and soluble in alkali due to the presence of strong electron withdrawing sulfonyl group. This will be your answer. Question number 26. You have to match the column. Benzene sulfonyl chloride, which is going to be the best pair for this. That is your approach. So this benzene sulfonyl chloride is used as it is also called Hinsberg reagent, and this sulfonylic acid is nothing but deuterion form, and diazonium salt can lead to conversion to alcohol, and this is your dye. So A2B1C4D3 will be option number B. Clear? Let's move to question number 27. Primary amines can be distinguished from secondary and tertiary by reacting with the following, which is the correct answer for this. It will be chloroform and alcoholic potassium hydroxide. This is the correct answer. The reason being, primary amines, either aliphatic or aromatic, react with chloroform and potassium hydroxide to yield isocyanide. Remember, it is a foul-smelling compound, and this test is called carbalamine reaction. It is not given by secondary nor by tertiary amines. Clear? Moving on to the next question, question number 28. It says, the indicator that is obtained by coupling the diazonium salt of sulfonylic acid with N,N-dimethyl aniline is? It is your methyl orange. Very simple question. Question number 29. Among the following, the compounds, the increasing order of their basic strength is? So how to answer this question? It is based on your resonating structure. The one which shows plus R effect, that will be your answer. Plus R effect means it gives dot electron, okay? And it is going to destabilize this. Destabilization takes place. The lone pair of electron is less available for protonation. And in this case, the second structure, if this goes, the lone pair of electron present on nitrogen will come here, and this is also plus R effect, plus R effect. But in the case of option number C, structure number 3, more plus I effect, less hydrogen bonding will be favored here in this nitrogen. Okay, so plus I more favored or more preferred than hydrogen bonding. It is due to steric hindrance. Okay, that is the answer. So unstable one to stable one. Make the proper sequencing. And for this last structure, more hydrogen bonding is present and less plus I effect. So when you make the proper arrangement, the structure number 2, this one, will be the least stable, followed by this structure number 1 here, then followed by structure number 4, then finally you have structure number less hydrogen, more plus I effect, structure number 3. So 2, 1, 4, 3, you find the answer 2, 1, 4, 3. C will be the answer for this question. I hope it's clear. Question number 30. The correct order of basicity of the following compound is, which is the correct answer for question number 30. So basicity, right? The number of lone pair electrons on um, nitrogen. This will be the first structure in accordance with the correct order of basicity. C will be the highest. Next is amine. Okay, it has electron withdrawing group. So followed by A. So when you make the sequence, it will be like this. That is C, B, A. It will be C, B, A. So the most basic will be this one, C, followed by this one, aniline, followed by nitro. So number C. Question number 31. Which one of the following compounds cannot be identified by carbalimine reaction? Very easy. Just find out which is secondary. Alright. So option number 2. Question number 31 will be option number D. This is secondary. Carbalimine reaction will be important for your exam. Question number 32. A, a compound with molecular mass 180 is acylated with ethanol chloride to get a compound with molecular mass 390. The number of amino groups present per molecule of the former compound is. So since the amine has molecular mass of 390, you should know that molar mass of NH2 group, if you would calculate, this becomes 14 plus 2, this is 16. So find the answer for this. See, since the molecular mass increases, how many times? From this NH2 it is 16, and for amide, RNH, whenever amide comes, the formula will be NHCO CH3. When you do the calculation, this will be 7 plus 1 plus 12 plus how much? 16 plus 12 plus 3. I hope when you calculate the answer will be 50 and 8. Okay. So since the molar mass increases 42 unit as a result of the reaction of 1 mole of ethanol chloride with one NH2 group, and the given mass increases 210 times, you can easily find the answer according to the question. 210 divided by 42, the answer will be 5. So answer will be option B. Question number 33. Reaction of cyclohexanone with dimethylamine in the presence of catalytic amount of an acid forms a compound. If water during the reaction is continuously removed, the compound form is generally known as. Write the reaction to answer the question. This is your ketone. What kind of ketone? According to the question, cyclohexanone. This cyclohexanone on treatment with dimethylamine. So how to write the structure of dimethylamine? So when this is treated with dimethylamine, it forms a tertiary amine. Further hydrolyze this, dehydrolyze this, water will be removed, condensation take place. This bond will be given here, and this OH will be gone as water molecule. Finally, you have NCH3 2. So what is the name of this structure? This is called, it has double bond, so we call it enamine. Okay, so the name of this compound we will call enamine. Question number 34, match the column. It's easy. Acetamide, let us see, it will be neutral. Benzonitrile will be also neutral. Triethylamine will be basic, phenol is acidic. So when you do the matching, A3B3C2 D1. So option A. Question number 35. An organic amino compound reacts with aqueous nitrous acid at low temperature to produce oily nitrosamine. The compound is. So since the organic compound, the amino organic compound on reaction with nitrous acid at a low temperature produce oily nitrosamine, the organic compound is usually your secondary amine. Secondary, not aromatic, it should be aliphatic. So which is the answer for this question? Secondary, you have to find secondary. This is primary, this is primary, this is tertiary. So option number C will be the correct answer for this question. I hope it's clear. We are left with only 10 questions. Bear with me. I hope you're all catching up. Remember, persistence is the key. Okay, question number 36. Nitrosamine, this is the formula of nitrosamine, are insoluble in water on heating with concentrated sulfuric acid. They gave secondary amines. What is the name of this reaction? This is your rearrangement reaction. This is your Fries reaction. Clear? Let us erase this. Question number 36. 37. In which of the following two-phase reaction the catalyst works by which of the following method? So in the first case, you have removal of this potassium ion from organic phase to make cyanide more electrophilic, nucleophilic. In the second, removal of this bromide. Third, transfer of cyanide. Fourth, transfer of this uh, haloalkane from the organic phase to the aqueous phase containing cyanide. So the answer for this question will be transferring of the cyanide from the aqueous phase to organic phase. So option number C will be the correct answer. Let us move to question number 38. Match the column, list 1 and list 2. In the list 1 part, you have, this is question number 38, right? So propine pellings, this is your, it forms a precipitate with silver nitrate. Then ethyl benzoate insoluble in water but dissolves in aqueous sodium hydroxide solution upon heating. Acetaldehyde reduces solutions. Aniline dissolves in dilute HCl. So match the column A2, B3, C1, D, D4. So answer is very close in D. This is the answer for question number 38. Let us see question number 39. All the three amines, primary, secondary, tertiary, reacts with which of the following? Can you answer this? Very easy. It reacts with water, it reacts with haloalkane, it reacts with HCl, but not with this anhydride. The 1, 2, and 3 will be the answer for question number 39. Question number 40, Hinsberg reagent. This is also a simple question. I hope you can answer this quickly. Hinsberg reagent. It is option number C. Learn to also name these reagents if possible. Okay, we are left with only 4 questions. Which one of the following amines can be prepared by Gabriel thalamide? Gabriel thalamide. So remember the reaction. For the preparation of this amine, the required alkyl halide will be the carbon, which is adjacent to 3-methyl group. It will react with the potassium thalamide, which is a strong base, to form alkene rather than the substituted product. So for preparing this aniline, you require chlorobenzene, which will be the starting halide in which chlorine will be non-reactive. So it must be either 1 and 2. D will be the answer for question number 41. Question number 42. When phenol and benzene disonium chloride are coupled, the main product will be coupling reaction gives colorful compounds. Okay. So when benzene disonium chloride is treated with benzene disonium chloride, I will write the formula here. When this is coupled with phenol, an orange dye is formed. So B will be the answer. Para hydroxybenzene is formed. Option number B. Okay, question number 43. Replacement of this disonium chloride from benzene disonium chloride can be done via which of the following reagents? Can be done by adding potassium iodide. Solution for this question number 43 will be option number D. Let us move to question number 44. You're asked to find Z from the schematic reaction scheme. Z in the above reaction sequence is, so on addition of sodium cyanide to this chloroethane, you're going to have ethyl cyanide. Then the catalytic hydrogenation gives amine. Can you name this amine? Propanamine. On further treatment with acetic anhydride forms CH3CH2 amide, secondary amide. Answer will be Z will be, yes, these two are very closely the same structure. Okay, last question as usual. You have to do this as homework and tell me the answer in the next class. The question for the last question is, towards electrophilic substitution, the most reactive will be nitrobenzene, aniline, aniline hydrochloride, and acetyl aniline. Tell the answer in the comment section. Okay, thank you. We'll wind up here for today.